Welcome to today's class. In this lecture video, we are going to discuss about the problems in portfolio evaluation. Now, to understand the portfolio evaluation problems, and finally you'll be able to apply the portfolio evaluation problems in realistic worlds, and you will be able to solve the various problems related to portfolio evaluation and try to evaluate the portfolios. First thing, Sharpe ratio. So, how to solve the problems related to Sharpe ratio? This is what the formula for Sharpe ratio. So, Rx minus Rf, X is nothing but the return of investment. Rx is nothing but a return of investment, and Rf is the return from the risk-free asset, or we call it as the treasury bill is called as a risk-free asset. So that's why the Rf is nothing but a risk-free rate of return. And the second, the denominator, that is standard deviation of the market return, that is in Rx. So whatever the investment that you make it, so for this investment return, how much standard deviation is observed will be taken here. Now, for example, if the investment manager A generates a return of 15%, means a portfolio through which manager A has generated 15% return, whereas the portfolio manager with his investment B generates a return of 12%. So A have generated 15%, B have generated 12% return. Now it appears that the portfolio manager A is the better performer. So if you look at the return, so from the returns perspective, the portfolio manager A have generated higher return, or that's the reason why it will be termed as the better performer. However, if a manager A took higher risk or larger risk than the portfolio B, it may be that the manager B has a better risk adjusted return. We could understand. So now let us see. If you continue with this particular example, say the risk-free rate of return is 5%, and a manager A portfolio has standard deviation of 8%. So means with a standard deviation of 8%, with the risk-free rate of return that is 5%, the portfolio manager A has generated a return of 15%. Whereas for the risk-free rate of return 5% and the portfolio manager B, the manager of portfolio B has generated with a standard deviation of 5%. So the standard deviation of A is 8%, whereas the standard deviation of B is 5%. Now the Sharpe ratio of manager would be 1.25. So means here for the portfolio manager A, wherein the return is 15%, the risk is 8%. For the portfolio manager B, the return is 12%, the risk is only 5%. Now it's very difficult for judging the portfolios if this is what the scenario. So that's the reason why the Sharpe ratio comes into picture, wherein you can apply the Sharpe ratio and calculate this Sharpe ratio, and based on that the Sharpe ratio value will be able to evaluate the various portfolios and try to judge whether a particular portfolio is a better one or not. So in terms of risk, if you want to calculate whether you want to evaluate the portfolios, whether they are better one or not, then you can apply the Sharpe ratios. So in this example, if you see, for the portfolio manager A, where the Sharpe ratio if we apply or use these values in this particular replace the values in this formula, the return for portfolio A is given as 15%, risk-free rate of is 5%, standard deviation given as 5%. So sorry, 8% for the portfolio A. So wherein the manager has generated this kind of return. So where if you calculate the Sharpe ratio for portfolio manager A, it is 1.25, whereas since the standard deviation of the portfolio B is only 5%, so the Sharpe value for the portfolio B is 1.4. So if you look at the Sharpe ratio value, so then portfolio B is considered as the best. So the top performer between the A and B, so B is the top performer than A based on the Sharpe ratio. So this way, risk adjusted basis we can calculate and evaluate various portfolios and try to judge whether a portfolio manager is performing well or not. So for some insight, a ratio of 1 or better is good for the for the valuation. 2 or better is very good, and 3 is even more and excellent. Now the Jensen's ratio. So Jensen's ratio is nothing but a alpha. So a return of the market with the risk that is taken. So now where RI is nothing but a realized return of a portfolio or an investment. Where RM is the realized return of appropriate market. It is nothing but a market return. And RF is the risk rate of interest or risk rate of return. And B is the beta of portfolio of investment with respect to the chosen market index. So this way, we are going to find out the return of the portfolio for the risk we are taking. Now let's consider one example for the Jensen ratio. Let us assume that a mutual fund realized a return of 15% in the last year. So last year it has generated 15% return. The appropriate market index for this fund has given a return of 12%. Let's say Sensex. If the Sensex has given a return of 12% and the fund has realized it with a return of 15%. Good. Now the beta of the fund versus the same index is 1.2, because if you calculate the beta value and the beta of the fund versus the same index is 1.2, because the fund has generated 15%, whereas the market index has given a 12%. So out of this, if you calculate the fund, the beta of the fund with the market index is 1.2. That is what the beta value of this particular portfolio. And the risk-free rate of interest is 3% is considered. And now funds alpha can be calculated. That is return of a portfolio given in the problem, that is 15%, and 3% is the risk-free rate of interest, and beta of the given portfolio, that is 1.2, and the return of the market index, that is 12%, and the risk rate of return, that is 3%. So if we calculate, now the alpha of the particular mutual fund or the particular mutual fund is 1.2%. So the market has generated the index has, or the particular mutual fund has generated 1.2% of return, which is more than the market return. So now, given the beta of 1.2, the mutual fund is expected to be more riskier than the index. Absolutely, when the beta of 1.2 means when market goes up by 1%, then the stock goes up by 1.2%. And the stock goes down by 1%, and the stock goes down by 1.2%. So means it is more riskier than the market index. That is the first one. And then the positive beta in this example shows that the mutual fund manager earned more than enough return to be compensated for the risk they took over the course of the year. So that's what the positive alpha when you look at the return of the index or return of the mutual fund. The return of mutual fund is more than the market index, which is nothing but the excess return that is being generated over the market index return. So that is a good sign. And if a mutual fund only returns 13%, then it is very unattractive, because the index is 12%, generated 12%, and the portfolio generates 13%, which is not attractive. That is also can be shown in the form of alpha, where if we calculate the value of alpha with this mutual fund return, that is 13%, then you will get minus 0.8% as the alpha value. So means even then the return of the market, the return of the mutual fund gives more than the market index. Like the market index here in the problem given as a 12% return. Even then the mutual fund generates 13% return also. The overall alpha that is being calculated by this Jensen ratio is only minus 0.8%. So means with a negative alpha, the fund manager would not have earned any return in terms of risk what the mutual fund is being taken. So that way we are going to evaluate the return of the portfolio in terms of the risk that is being taken in the Jensen ratio. The next ratio that is used by the various portfolio managers for evaluating various mutual funds, that is Tranner ratio. The Tranner ratio judges how efficiently the fund manager achieves the balance between the return and the risk of a portfolio. Here the risk is the market risk, means how far the portfolio is reacted with the market risk. So unlike the Sharpe ratio, it makes use of the data as the denominator. So that's why the main difference between the Sharpe and the Tranner. So the Tranner ratio is the RP minus RF by beta P. So RP is the return of the portfolio, RF is the risk rate of return, and beta P is the beta of the portfolio. And if you take the problem, suppose the average return generated by the fund manager by your fund is 10%. And if the risk rate of return is 6%, the difference between the fund return and the risk free comes down to 4%. Means the fund has generated 4% return for the risk that you are taking. So if the fund's historical beta is 2, then the Sharpe ratio will be taken as the 4 divided by 2, that is 2. So it implies that the fund gave 2 units of return for every additional unit of market risk assumed. So means for a unit of for 1 unit of additional market risk, the fund is going to earn 2 units of return. So while comparing between mutual funds, we will use this Tranner ratio to arrive at the ideal fund, which one is the best. So the Tranner ratio, a higher Tranner ratio is the better for compensating you the risk with the return that you are going to achieve. So this way, the Tranner ratio is more, and the considered mutual fund is a better one. So that way, the Tranner ratio is going to help. So this way, we